finish there. Okay, we'll turn it off now. Hi, this is Steve Barton. Today we want to talk about some of the tools that we use over here. Most of these I have made. Michael Hochstetler, I hope I'm pronouncing that name right, he mentioned in our last video, he's talking about this little 1-inch cutter that we were using in the opening of our video, and he never saw one before. He was wondering what it was. Well, this little cutter right here, it's a MillTech cutter. I'll put a link to their homepage down in the description area. But it's one of my favorite cutters. Not so much the 1-inch cutter, but this style insert. This style insert, it's called a Super Shear. It comes in the square, comes in the round, and it comes in the octagon. And you can get them coated or uncoated. They have a 20-degree relief on the side here, and they're dished in on the front. And these are the Super Shear series. Very free cutting. They like the RPMs, and they leave just a tremendous finish, a really smooth finish. If you watched our last video when we were making these little clamping units, setup blocks, I mentioned in the video that the flatness of them were within thousandths on there. If you remember watching the indicator move, you can see how fine of a finish that is left. I like buying the square cutters. Well, before I go there, all three of these cutters will fit in the same holder. But I like buying the square cutters because I can just take them once they dull up. I can just take them to the grinding wheel, and I can just put a nice little radius on there, and I can go again. So I can take a box of these inserts and I can cut a lot of steel with them. This 1-inch one is a bought tool. If I remember right, they had a special going that if you would buy one box of inserts at the time, and then you would get the free 1-inch cutter. I think it was something like if you bought 2 boxes, you can get like a 2-inch face cutter. And they got them in a shell mill style. Now this one was purchased, but these 3 cutters, they're using the same MillTech inserts, and these are homemade cutters. I made these with an R8 shank, so it's one solid piece, rather than having a shell mill. This is a lot more solid, and I've used these for decades, and I can tell you they can really remove a lot of steel real fast. And the nice thing about it is with the Super Shear action, all the heat is going into the chips. Your parts stay nice and cool. You don't get much distortion in your parts. This one here has 2 inserts. I think, if I remember right, it's about 1 5/8 diameter. What I'll do is when I make these with a 10-degree, because you get 20-degree relief. I make this at 10 degrees, so I still get 10 degrees relief. And then I make it at 2 degrees over here, so that I'm cutting with the tip rather than the entire flat of the bottom. So I won't get a square shoulder, but I use these mainly for just like you would use a face cutter. And like I say, they can take a lot of stock. You can take some nice heavy cuts with these things. They love the RPMs, and if you crank them RPMs up real nice, you can get a nice feed rate. One of the fastest ways to remove metal. This, I believe, was a 1 5/8, and I tried to make these cutters so that they were about 1/8 inch bigger than the nominal size. This is one that I made. It's got 3 cutters, and I think it's about 2 1/8. And then this one is a 4 inserts. And I believe that was about 2 5/8, if I remember correct, in the diameter. I've been using these for a couple decades now. Super product. These inserts, they're some of my favorite. If you guys are interested, check out the description, check out their website, and you can see what they have to offer. one of the other things that you use quite often is boring bars. I've made numerous boring bars in the past, some of the more simpler ones. This is just out of, I believe it's A2, that's what I make most of my tools. I usually make these so I can fit them up in a boring head. You can also use them in a lathe, so a lot of times I'll use a 3/4 shank. These ones are quite simple to make because all you have to do is just set this up at a 45 degree. Let me get it, 45 degree, and drill and ream a hole. Now, what I use on these is I use broken center drills. I'll take the broken center drills, I'll drill and ream for whatever size center drill I plan on using. I'll put a tap coming at 90 degrees that way. And so you can take a broken center drill and then you can just take it to a grinder and you can shape the end, radius it, put whatever shape you want, and it works real nice. The nice thing about this is if you want some carbide, you can just have some carbide center drills. Or you can take, like this is 3/16, if you have some broken 3/16 carbide end mills, any of those broken pieces of carbide you can put in there and grind the shape whatever you want on the tip. So they come in very handy. This is just a solid 3/4, but the same principle, and this is using a number 3 center drill, so it's a 1/4 inch. And again, you can use carbide or high-speed steel. Here we got a more fancy a boring bar. This is homemade. This is using a chip breaker, and it's using that mainly because I made these to use ceramic inserts in there for hard turning, and that would give me a more even pressure put on that insert. But I originally made this design of a boring bar with this clamping system when my full-time job we were doing hard turning, and we're having a hard time finding a good boring bar that would hold a 321 insert without a hole in it, just a solid insert, holding it without it being able to move. With hard turning, there's a lot more pressure on the insert, and if you take too big of a cut, you're going too fast, a lot of times that insert with a lot of the boring bars on the market would just spin in its pocket. With this clamp design over here, I don't know about now, but at the time we couldn't find anything on the market. This right here, I could take a 50 thousandths depth of cut. It's 25 per side. I can run at a pretty good feed rate. And the only difference in the hole size that you might measure is it wasn't from the insert spinning on you and cutting oversized, but the bar pushing with the pressure of that high depth of cut pushing off a little bit. So this particular bar will hold those inserts in better than anything I've seen on the market and without spinning. We also make that same style. This is out of A2. I cut it off short so I can use it in my boring head. This is a 5/8, the same style. This one right here, what we'll do is we'll make them out of carbide. We'll take a steel head and we'll take a carbide shaft and we'll grind a shape similar to this backside over here. We'll grind that shape, and then we'll take one of these steel heads and we'll put that same shape, and of course this is a big one, but you put that same shape in there, and then what we'll do is we'll use silver solder, and you want to use as close as you can get to a 50-50 silver solder. And if you do a good job silver soldering, that stuff is extremely strong. If you crash and break, it will not break at your solder joint. It will actually break that carbide off. If you're boring with this and it gets a little bit too much pressure and your silver solder joint's not good, a lot of times then the head will just fall off. But you can make just the heads of these. Like I said, you can bore or put whatever shape you want in the back, whatever shape on the carbide, silver solder them together. Once I get them silver soldered together, I'll take them to OD grinder, set them up, and I'll just true that up so it's real nice. But those bars work very good. This one here is 5/8. This one is a 1/2 inch. And what I have over here, and we'll probably use this in a future video, one of the tools I have is I have a fixture for making boring bars, for putting the actual pockets in here. And so this is a kind of a nice little fixture, because you can hold this in the vise. You use whatever insert you're using. Some of them have 7 degrees, some have 11 degrees. So you buy your end mills with the taper on them, get them the right size. And with this fixture, what you can do, there's a little screw that will clamp this unit down on the side. I'm just going to move that out. I have a dowel hole right here, and this particular one is made on this closest hole. It's for a 3/8 boring bar. That's for a 1/2 inch boring bar, and this one here would be, I think it was for a 5/8 boring bar. I'm just going to set this in here on the second hole, or on that hole, which would be set up for a 1/2 inch. You get your, what I would use is most time I would use a A2 drill rod, and you would just stick that in there. What you would do is you'd set this dowel pin in. Well, let's see, I'm going to have to go to this one for demonstration. Okay. Oops. Let me get the right holes here a minute. Yeah, there we go. Yeah, so I got 3 holes here to determine what size boring bar you're using. And then over here I got 3 holes that correspond. And then I got 3 holes in here, and then I also got the tap hole in there. And what you can do is you can move that up, it'll pivot on the hole, it'll come down over here. And you can clamp this down. You can take your tapered end mill, and you'll be able to cut, you know, if this is set in your vise. Now you can cut that wall. You can pull that up once it's cut, move it over here, and now you can cut this other hole, or the wall. And then you can move it in straight right here, and you can take a straight end mill and you can cut the relief in, so the tip of the triangle can go in there. And I have this set up so that when you're set over here, it's set at a 5-degree angle here. With a 5-degree angle, you can go up against the shoulder, and then you can face it off real nice. So I got 5-degree relief there, and I got a 5-degree relief that way, so that we got a compound angle going on that. But what we'll do sometime in the future, we'll probably come back and revisit this and actually show you in detail how we make these boring bars. But it's just one of the tools that we have that we like, and I use quite a bit. This tool, this is a fine adjust tool right here that we have, that I can use in along with my spin fixture. And I'll just show a picture of what we've been doing. But if you take your spin fixture, yeah, well, we'll wait on that. We'll just show it in the picture. But I can mount this up on the spin fixture on the front with a screw hole in here. And if you got a long shaft that's sticking in there that you need to grind nice and smooth, a lot of times your wheel pressure will cause it to dip, or it may not be setting perfectly flat, and in a long length you're going to end up with taper. This is a spring unit. You can see how it's springing in and out, but it's also got a fine adjustment. And the head on this, I just got some dowel pins in here. They can be cut down, but I did this kind of a rough prototype. I'll refine that in the future. I got a friend that's wanting one of these, and so I'm going to give him this one, and we'll be making another one. But they're basically using a die spring. It's hollowed out in the bottom here. And then I got this set so that I can adjust this up and down. The nice thing about this is when you got a long piece in your spin fixture and you want to grind and you end up with taper in it, you can set this underneath it The part that I'm showing in the picture, originally it had about a little over a thousandths taper in that. I think it's about a thousandths and 4/10 if I remember correct. But I could set this unit under here. I can set the indicator on top of the round bar, and then I can zero it out, and then I can just dial this in until it moves up half of the amount of taper I had. Set it back up on the grinder, and when I would grind it out, the first time it come out just perfect. So if you're using a lot of long pins in a spin fixture, a unit like this works really nice. So these are just some of the things that we have made in the past that we use quite often. You'll probably see some of the stuff in our future videos. Some of these cutters you've already seen in some of the past videos. And one last thing that we want to show is DJ Berg. We had our coolant tank, and we've been working on our system, and if you looked and saw some of our previous videos, we don't like to have the video going or the sound going when our coolant tank is on, because it's very loud. With DJ Berg, he mentioned about using one of these hydroponic submergible pumps that you can get, and it's submergible and it's real quiet. So this weekend we got this set up, and Adam will probably play a clip where you can hear how loud our old pump was. That was this unit right here on the floor. And here's what our new one sounds like. So you can see it's a lot quieter than what we had before. Nowhere near as amount of noise. You'll be able to hear the grind. We got about the same pressure. And DJ just said find out how many gallons per minute. I think this was like 10 gallons a minute. And this is real close to 10 gallons a minute. The one thing you got to keep in mind is the heights that we're coming up. We're coming up about 5 foot from the ground, and so you want it to pump a pretty good volume yet at a 5 foot height. Well, anyhow, we're just going to do a short video this week. Adam had to work the whole weekend, and so we thought we'd just try to get something short out. We hope you enjoyed. We'll see you next time.